right. Hello, everybody, and welcome to the stream. Hope everybody is doing well. Me and Mr. Mustard, it's good to see you. You are early today, actually. Welcome, welcome. So today we're going to pick up where we left off yesterday. I did get some stuff done, actually off camera, to help speed things along a little bit. So I did make some progress there. We'll quickly review some of that stuff. Not in great detail because I kind of want to get back to coding, but yeah, we did make some progress there, which is good. That'll help. Before we jump into that, though, I do want to just take a quick second and thank the supporters of the channel, beginning with our partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are Furkan Tokan, and Gerboles Inc. I would also like to thank all the other supporters listed here as well. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. Helps me cover costs associated with the project, and things like hosting, equipment costs, licensing, things like that. So all of that stuff is going to come very handy when we start actually developing the game. So with that, I do also want to take a quick second just to thank all the viewers who are here with us, whether you guys are just catching the VOD afterwards, or whether you are joining us live here on Twitch or on YouTube. And I point to different monitors that I have here because we simulcast to both. I keep an eye on both chats. This is designed to be an interactive stream. So, I like chatting with you guys. So feel free to jump into chat and we'll talk. TPT Sam, how's it going? Good to see you. Welcome. Me and Mr. Mustard, it's good to see you as well. You say you're not doing well, though. That's unfortunate. I hope it gets better soon. I do understand that. Negative Pointer, how's it going? Salutations to you as well. Ruche, thank you for the emote there. That's one of my favorites that Spiro has. Appreciate that. All right, so what we are doing tonight is we are basically switching over our texture system to use the new resource system. And along with that, we are changing our material system, which is pretty tightly integrated with our texture system, or at least it makes use of it. And so that is kind of what we're in the middle of doing now. It's kind of both of those things at once. So basically what we're doing is we're changing all of the usages of the texture system within the material system. We're going to flip that over first. And then once we have all that, we'll come back and we'll actually change the material system itself when we load materials to use our new format, parser, all that other good stuff. So again, we're just going to kind of keep iterating on what we're doing, keep building up, and go from there. You're bummed that you failed a test online that would help you land a job at an IT company. Well, I certainly understand that. I've failed no shortage of those types of exams myself. Sometimes you just get questions on there that just either you don't know or your nerves get the best of you. And, it happens. It's a part of the process, unfortunately. It sucks. We've all been there. And as long as you keep your head up and keep trying and study and keep taking stabs at it, don't give up, you will land it. Just be more stubborn than it, is what I can say there, So yeah, definitely, keep at it. Don't let it bum you out for too long. I do understand that feeling. I've been there many times myself, though, so you're not alone in that either. All right? Let's see. Negative Pointer, you're doing DLL stuff. I don't like doing DLL stuff. Have to do DLL stuff anyways. Yeah, I mean, we all have to do DLL stuff at some point, right? We do a lot of that in here, actually. We haven't done it recently, but hot reloading and things of that nature are always fun and not fun at the same time. DLL hell and all that. I do understand where you're coming from on that. You're letting it bum you out tonight, but tomorrow's a new day. That's a good way to look at it, Give yourself time to think about it, recover from it, and move forward, Okay, so I guess probably the first thing we should touch on is we talked about some of these changes last night when we left off in the stream, and I was kind of thinking that we needed to make some interface changes in how we actually handle resources. So let's take a look at that first. Okay, resource system. And so let's see. Well, I guess actually let's step into. Now we'll start with the header file first. All right. So what we did last night was we were thinking about changing this interface. I have changed this interface now. And so the K resource system request now immediately returns a pointer to a resource. And the way that this works now is the way that I was thinking. I had already programmed it before, but hadn't quite got to because there were to-dos in the code. So I've resolved those to-dos. And now the resource system itself is the owner of all resources. That way there's no question of who owns it, right? And the only thing that we ever do is we return a pointer to a resource whenever we request one. So when we make this request, it is an asynchronous request still, or it should be thought of as such, but we are immediately given a pointer to a resource. So the way that this works is whenever we request a resource, we immediately sort of stand up a structure with some basic properties within a internal lookup table that we have. And we go ahead and kick off the internal resource handler for that specific resource type, and hand that off to the job system and let it rip. And then we immediately return a pointer to that resource. And that resource at that point is generally speaking going to be uninitialized, right? And there's some exceptions to that, and we'll get into that in a minute. But we immediately have that so that we don't have to worry about handling it on a callback, right? And so the request info still actually does allow us to provide a user callback if we want to, but it's now no longer required, right? It's only actually used if it's provided. And in a lot of cases, I would argue most cases, we're probably not even going to have to use that, right? It's just sort of an option to let us execute a little bit more logic once the actual resource is loaded. 90% of the time, though, I don't think we're going to need it because we now have this pointer to the resource, right? So we immediately get a pointer back. This is immediately stored in our resource system, and we don't have to worry about the life cycle of this, right? So that's the biggest change. Another change is to the resource system config. So we had this sort of dummy in here before that we weren't really using for anything, and now we have a max resource count. There's nothing actually pointing to this though, so we are going to have to resolve that to actually fill that out. But that's another item to do on the list. So if we check out the initialization of this system, we do a couple of things. We take a copy of the max resource count. We create a lookup table, which has a bunch of these resource lookups. So if we peek the definition of that, a resource lookup is similar to what we have done for the assets, right? It contains the actual resource itself, right? So the resource itself is owned by the lookup, right? It contains a reference count to that particular resource. And it also contains a flag as to whether or not that resource should be auto-released. I've done this as a Boolean for now, just because we don't have more than one flag at the moment. But if we ever do have more than one flag, we'll likely convert this into like a bitwise integer with a bunch of flags and stuff, and we'll use flags instead. But for now, a single Boolean is enough. So auto release basically says if the reference count of the resource lookup ever reaches 0, then we go ahead and we release the resource, right? So that's the way that works. We also initialize the lookup tree, which is right now just a binary search tree. I'm probably going to wind up replacing that with an array version of that, so we don't have all the indirection going on. But I happen to have one of these laying around, and it was quick to just slam it in, right? So we initialize that to 0, meaning there's no entries in it, right? And then on shutdown, what we do is we then go through that entire resource table, and if the lookup has a name assigned to it, which is essentially saying there is a resource in this particular slot, we go ahead and we release that resource. We have this k resource system release internal, which is just a internal static function, because we actually call release from more than one place in code. So I split that out into its own function. We clean up the search tree. We free the lookups array, and we zero out the state when we shut down, right? So pretty self-explanatory stuff there. The meat and potatoes of the request now looks very similar to what we have in the asset system, right? So the first thing that we do is we attempt to look up get a lookup index rather. So the way that this works is the index is by name, right? The k name, which is our 64-bit integer that's unique, that's generated based off of a string, right? So that's the hash of a string. And what we do is we search our tree, and the tree keys are the name, right? So we search for the name there. And this will return a node if it already exists, meaning we already have that resource loaded. It's already existing. All we need to do is return a pointer to it. And if not, then this will be a null pointer /0 that gets returned. So if we have a node, we go ahead and we set the lookup index to that node. And in this case, that particular value for that tree is stored in the U32 portion of that union, right? So we do that, and then we say if the lookup index is not invalid ID, which is what it defaults to up here, then we go ahead and we grab a convenience pointer to that lookup. We increase its reference count. If it has a user callback defined, we call it, and then we return a pointer to the reference within that lookup, right? And so this is the case where a resource system request is immediate, right? So the resource that's returned here is probably loaded already in that case, and is ready to go, right? But if we do not have an existing resource, then we need to go ahead and create one, right? So what we do is we loop through the lookups table, or the array there, and we look at each individual one. We say, okay, does this name have an invalid k name, which, if you recall, is just 0, right? Which is the default value for that entire array, right? So does it have that invalid name? That means that that particular slot is free, right, at that index. So in that case, we go ahead and we create a new node in the BST using the node value here, which has the U32, which is the index, right? So that is, wait a minute. Yes, okay. So that's the value of the node that we insert, right? So the way this BST works is the key is the name, right? So we insert for the name, and then we go ahead and insert as the value the index, right? And so that just becomes a lookup into that array. If for some reason I shouldn't say for some reason, if we have not yet had an entry into the BST, it's the first entry, right? State lookup tree will be 0, as we saw in the initialization code. So the new node that's generated becomes the lookup tree's base node, right? And then everything gets inserted from there, right? So we handle that if we need to. Then we go ahead and we set up the resource, right? So we set up the name, the type, we default the state to uninitialized. We set the generation to invalid ID, which means it's not been loaded. And then we zero out the tag count and tags because we don't actually do anything with those yet. They're just kind of there. We then grab a handler for that particular type, the resource type. And if the request function is not existing for that, then we go ahead and throw an error and return a null pointer. And so that will help us identify any of these that are improperly set up. Otherwise, we go ahead and make the actual request. So we call the handler request function pointer, passing the handler itself, a pointer to the resource, and the info for the request. If that request is successful, it will exist. If it's unsuccessful, it would not exist. So if it's successful, we go ahead and we plus the reference count, right? So we start off the lookup's reference count is automatically 0, right? Which we probably ought to, now that I'm thinking about it, we should probably we should probably do this, right? We should probably just make sure it's 0. It should be, but let's not assume that. So we go ahead and this will essentially flip it to 1, right? And then we return a pointer to the resource. And then if for some reason the request was unsuccessful, then we come all the way down here, we bleat about it, and we return a null pointer /0. If for some reason we have iterated the entire list, right, of resources, and we did not actually return at some point, meaning that we found an index, right? In this case, we return here on success and we return here on failure, right? So if we have an index here, we would have broken out of the loop, right? So if we have not returned at this point, then we say the max configured resource count of whatever that is has been exceeded and all slots are full. We need to increase it, right? And that's a fatal message. And so that'll just allow us to, or prompt us to basically change our configuration. That's really only something you'd ever have to change during the development cycle of your game, right? Because once you're in runtime, you're never really going to hit that, right? You'll know what your max needs to be. In this case, we return a null pointer as well, all right? So K resource system release is now just calls that release internal, right? So like I said, I just split that up because we call it for more than one place. Now you'll notice here that we're passing a false, and in what was it, shutdown, and in shutdown we're passing true in the last parameter, right? The reason for that is that is force release, right? So when we're just releasing a resource under normal conditions, we don't want to force the release. But if we're shutting the resource system down, we absolutely want to say whether this is supposed to auto-release or not, we want to force the release of this, right? We always want to release it. And so that's just a little internal flag for us to know to do that. And so the way that this works is it basically, does the lookup as we do when we're retrieving a resource. And then it goes ahead and does the lookup count, or it looks at the lookup count, right? So we have this do release that defaults to false. If force release is true, right, then we actually set its reference count to 0 so that it will release and say do release equals true. If we are not force releasing, then we decrement the reference count, and then do release is our old criteria, which is saying, well, if it's auto release and the reference count is -1, then we want to do the release, otherwise we don't. And then here, if do release, we go ahead and release, right? So this basically just calls the resource handler release if it exists, and then it comes down here and resets everything in the lookup so that we can use it for something else. And that's about it, right? If the lookup index is invalid ID, we just warn, right? Because what that means is that we basically attempted to release something that's already been released, right? And so that's the resource system sort of changes that we made, and everything else that we are going to do or that we have done in the texture system kind of builds on top of that. All right, let me take a minute and just catch up with comments. Singy, how's it going? Good to see you. Welcome. Let's see. I got to scroll up a little bit on the Twitch side. Looks like I missed a few. Thank you for the follow. Appreciate that. Let's see. Programming is built on falling over and over. Whoever you are, you can do it. Yes, that was somebody on the YouTube side that was having a little bit of a rough time. So, Mean Mr. Mustard, that comment comes to you from a negative pointer over on the Twitch side. So, yeah, that's absolutely true. You guys see me fail all the time on this stream, right? I fail at stuff constantly. I'm always breaking things on here. We even have a freaking term for it here on this stream called dingus-oriented programming, okay? That's how often I fail on stream, so don't feel bad about it. Smudge, good to see you. How are you doing? You made a pull request with improved build documentation for Linux. Also working on Windows now as well. Awesome. All right, I really appreciate that. I'll have a look at that. I probably won't get it to it tonight, but I'll take a look at it tomorrow. And if I have any feedback, I'll let you know in there, and otherwise I'll merge it. So thank you very much for that. I appreciate it. Smiling Big, how's it going? Good to see you. Rune Life TV, good to see you. First time chat, welcome. Joined the Penguin Army today. So far it's been easier than I imagined. Okay. I assume that means you joined, that you installed Linux, which is awesome. One of us. Yes, absolutely. Yeah, so what distro did you wind up going with? I'm not one of those guys that has to say you have to use this distro. I say use whatever distro works for you, right? Pop! OS is a good starter one, for sure. I used it for a little bit, but I switched from Arch to that one, just distro hopping, just to give it a shot. And I liked it, but I liked Arch better, but that was for me, right? But I've also used several flavors of Ubuntu and a few other ones, right? But ran into a few issues, but been a lot less problems than I imagined. Yeah, and that's what Pop! OS really excels at. It's pretty stable, right? People seem to like it, not tried it. Yeah, so it is, I did like it, right? It's really good. It's just not necessarily for me, but I did like it when I tried it. I just kind of prefer the Arch way of doing things myself, but that's just because I have very specific wants that I've developed over the years. What is kassert message a macro? Yes, it is. So let's see, where did, I think that must have been this right here. Okay. Yeah, so what this does, this is basically, this is what it expands to, right? So we basically check the expression that's passed in. And if it is, if it's true, we do nothing. Otherwise, we report an assertion failure, which this essentially is a call to our logger, right? And then we call kdebug break, which is actually itself another macro that actually breaks the application in the debugger if one is attached. And then we have, let's see. Yeah, so it expands to this, right? In our case, it was memory requirement, so we want to make sure that that pointer actually exists. And then the message part gets spit out here, right? And it gives us the file path and the line number, right? And then in our case, since we're using Clang, it's built-in debug trap is what gets put in there. CM Griffin, Chris, Mr. Sir, how is it going? Thank you so much for the raid. I appreciate that. How are you doing today? What'd you get up to on stream? You got a raid and run. Okay, fair enough. Welcome, raiders. So I will, for the benefit of the raiders, I will give a quick intro to what we're doing. But let me first give a shout out to CM Griffin. If you're not following Chris, you should definitely do it. He's a GigaChad developer here on Twitch. Highly recommend following his channel, for sure. He's always open to good conversation and just having a chill time. So definitely follow him. If you're not, go check out his channel. He's usually working on some pretty cool stuff. His flagship thing, I would say, is his feature flag software that he writes. So definitely check that out. Ask him about it. It's pretty interesting stuff. All right, so let me give a quick intro as to what we're doing here for the raiders. So welcome, raiders, if you guys have not been here before. We are making what I'm calling the Kohi game engine. So it's a game engine that we are writing from scratch using C as the programming language and Vulkan as the initial rendering backend. It is cross-platform. So it's available on Windows, Linux, and Mac OS. We're currently on Linux at the moment. It is open source and free. And when I say that, it is available on GitHub, right? So I can actually drop a link there in chat. That is to the main website that we're looking at here. But just taking a quick look at the GitHub repo, which I pulled up from there. Here is all of the source for the project, right? We've got a little bit of an intro here. So what we have is, and I can't run it at the moment, unfortunately, because I'm in the middle of making breaking changes. But We have a very basic sort of PBR setup with lighting, shadow maps, cascading shadow maps, I should say. We recently added water to it, LOD terrain, all kinds of good stuff. The ability to select objects, move them around, scale, rotate, things like that in the scene. So we're building all of this completely from scratch, including like all of the font rendering and stuff like that. And this is Apache 2.0 license, which means if you want to use this for a personal project or a commercial project, all you have to do is say that you use that. That's literally it. There will never be any sort of licensing fees or royalties of any kind. It will always be free. The reason we're creating this is to be, it's basically an educational resource. So it's a way to build a game engine. It's not the only way. It's not necessarily even always the right way. And the reason is because we explore different things to see what works and what doesn't. So there's plenty of cases where we've tried things and it doesn't work. And there's plenty of cases where we tried stuff and it works spectacularly. And we do deep dives into those things along the way. And the idea here is I am creating the resource that I wish that I had when I was learning how to do this stuff, which includes, all of the steps, not only coding, but also debugging it, troubleshooting, design sessions, things like that. And so we have on this website here, we have links to the GitHub, our Discord server, which is approaching 1,000 people, YouTube and Twitch. We do simulcast to both. Patreon if you're interested in supporting my work, and then of course the live stream on Twitch is down here. And so yeah, that is pretty much what we're doing here on the stream. And tonight we are actually working on we're reworking the way our resource and asset systems work, and everything that ties into those to make them more decoupled and what we call jobifiable, which basically means that we can split off work to different threads and handle multiple resource loading at the same time. So multiple textures, multiple meshes, what have you, at the same time. That's the entire idea behind it. And so, yeah, that is what we're working on tonight, and we're in the middle of that. So I hope that makes sense. This is designed to be an interactive stream, so if you guys have any questions along the way, feel free to jump into the chat, say hi, and ask away, and I will answer to the best of my ability. All right, just catching up with chat here. So confirm new user. The transition seems to be good so far. Alt tab is working the same as a major point. Yeah, you'll find some overlap between Linux and Windows in terms of usability, especially on Pop OS. But yeah, you picked a good one to start with for sure. Let's see, Snowy API, welcome, first time chatter. You're writing a parser in C? That's awesome. Yeah, we actually, we wrote a parser for our own custom language format as part of this as well. So yeah, those are super fun to write. We're definitely going to write more of them too. Been super sure not to do anything sketch. Watch Linus Tech Tips. And he dropped his entire desktop using, yes, do as I say. Ugh. All right, so we have ads. Oh, you know what? I hit the button a little bit too soon. We don't have ads yet, but we have ads coming. So what I usually like to do on the stream is, I triggered that a little bit too early, is whenever we have ads, I usually pause the stream so that nobody misses any content, right? Because on a coding stream, it kind of sucks when, somebody is explaining something or you're kind of discussing something, and then you get that full screen ad and you can't see or hear what's going on. So I usually just pause the stream for that 90 seconds so that nobody misses anything. So that'll be coming up here in a minute or so. So I guess until that actually pops up, I'll continue coding. All right. So let's see. We went over the changes to the resource system, and from that we had to make some changes to our texture system. If we hop over to our texture system, whenever we, let's see, where was that? So it was requesting writable array. We had to change this to now use the new resource system request that returns the texture pointer, or the K resource texture pointer, right? We have to cast that. And so basically, if we don't immediately get a pointer back from that, then we know that resource request is going to fail. And we might find that out later asynchronously as well, but at least that's a surefire way to tell right away what happened. So we make a request for that, and in this case, it's a writable texture, so it's going to return immediately because writable textures don't actually have any data uploaded to them. Ads. So there's the ad break screen. And so I usually say, for any of those that can hear me, and I forgot to bring this up before we actually broke for ads, but I usually say go hydrate, go get something to drink, and come right back, and we'll be back in just a minute, right? And I also use this to catch up on comments a little bit too in the chat. So yeah, we've got about a minute left, and then we'll continue. I feel like I should do a poll at some point, because I know when I first started doing this, a lot of folks appreciated it, but I should probably check on that every once in a while. Issues kind of no, and maybe it is a simple fix. Which issue? Which issue do you mean? Assuming you can hear me. If not, I'll be repeating that in about 10 seconds. All right, almost done. And ads are dead. All right, so one thing I forgot to mention before is anytime the ad screen comes up, you guys know exactly how long it'll be before I get back. So if you need to go hydrate or bio break or something like that, it's a perfect opportunity, right? Let's see. 7900X graphics not working. Had to swap to second monitor onto GPU. Oh, that's annoying. Yeah, sometimes you'll find GPU issues like that. Weird graphics issues on Linux, but I don't know. I've had pretty decent success with it so far, on Arch at least. Just curious, why do you implement error message output through macros? So, that's a good question. So if we take a look at this, this is actually a, what's the term I'm trying to think of? A variadic macro, right? Which means it kind of works like printf, where you can include different arguments, right? So in this instance, I'm not doing that. But there probably is one in here where I am doing that, right? So in this case, it's like a built-in string format, right? And so if we go to definition on this, there's a few things that are happening here, right? So first off, we call this log input, or log output rather, which is defined in the C file. We'll get there in a second. It is also a variadic function, right? But the reason we have this tied to a macro is because we can actually turn off some of these functions. Now, fatal and error, we don't really turn off. Warning and info, I don't think we're ever going to turn off either, but the lower levels, right, like debug and trace, we actually have define flags set up, right, where we can actually turn that off. And the nice part about that is if we have this enabled, then it's defined this way for kdebug, right? Otherwise, it's defined as, and it might be a little hard to see here, but kdebug is defined as a no-op, right? So it just compiles it out straight, right? You don't have any sort of logic to say, oh, is this on or not on? It just doesn't even compile, right? And then we actually have, so we have the same for trace enabled, and then at the top of the file, we actually have the ability here to say, well, if we're building in release mode, then we turn debug and trace off. Otherwise, we leave debug and trace on. And we can very easily tie that to other build modes as well to sort of fine tune it a little bit as well. So yeah, that's pretty much our reasonings for doing it. And then furthermore, thank you for the follow, by the way. Furthermore, if we check out log output, which is going to be in logger.c, log output actually does some additional formatting for us, right? So it basically checks the log level that's passed in, which is also part of that macro that we had. So if we look here, fatal, for example, calls log output passing the fatal level enumeration value, right? Just like error passes error, right? Otherwise, you'd have to type this in all over the place. So it saves us from there as well. But in addition to that, we convert that into a string, right? So we have some strings here that are sort of predetermined in the correct order, right? So we can actually use that enumeration to index into this array, get the string representation of it. And then we, perform some string formatting in here to prepend this log level to the actual string. And then we go ahead and we send it out to our console as well as our platform console. So our console, for example, the difference between our console and the platform console is the platform console is basically the terminal, whereas the console is like our in-game debug log. It's eventually going to be like a network logger. So we have these things called console consumers that can hook in and receive any of these logger messages as their actual input, right? And so we actually have the ability to hook into that and provide or have console consumers that are responsible for outputting that. Eventually, in fact, actually, I think we actually set up platform console write also as a console consumer, but it's here also as a fallback in case we don't actually have a console set up, right? So the console is sort of a runtime, or like a runtime specific thing that we can set up, but it's optional. And so if we don't have a console set up, we don't have consumers set up. And so if we don't have that hook in there, then we just fall back to writing out to the terminal. So there's like a whole bunch of stuff that goes into this, and those logs go to different places and are processed in different ways. Probably more of an explanation than you were looking for, but there you have it. Okay. Heisenberg01, how's it going? Good to see you over on the YouTube side. Mean Mr. Mustard says from the YouTube side, he says, sorry for the late reply, but I really appreciate the message over on Twitch. So, yeah, awesome. Love it. We try to have a pretty supporting community around here. We try to build each other up, right? Rising tides lift us all up, right? That's the idea. All right. So talking about our texture system, right? So we were talking about the writable array here, or the writable textures. So we basically set up a request to the resource system, right? Just kind of passing in these values that are passed into the function, like width, height, texture format, has transparency, whether or not, array size, blah, 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 blah. And we set some flags, and then we go ahead and we make the request here, check to see if that failed or not, and then return that pointer that was returned from here, right? So the writable array is basically just a more extended version of request writable, which sort of defaults to texture 2D and a single layer, right? So this really just calls down to this guy, and this is what actually does the work. So we needed that for our font system. And then the other portion of that was our texture system request. So our texture system request now returns directly a pointer to a k-resource texture. And that k-resource texture is not owned by the texture system anymore. It is actually owned by the resource system now, which is the way it should have been from the beginning. So we go ahead and, in this case, let's see. Default texture by name. We probably ought to rename that. What this function basically does is it checks the name of the texture that we're requesting to see if it is if it matches up to one of our texture system's default textures, right? So we have different default textures for different types, and the reason behind those is if we attempt to load some type of texture and we fail at that, we have a fallback texture that we can use that we know works, so that we don't crash the renderer for saying, oh, we tried to load a texture and it doesn't exist. We just use a checkerboard or something, and it still is able to render, but it obviously very obviously looks wrong, reports it to the console, and you can troubleshoot it versus stupid null pointer issues or something like that. So it attempts to get a default texture by name first, and it does that simply by looking at the name. Now, as a refresher, this is not a string comparison. A kname is just the type def for U64. That is a U64 hashed string, right? So we string hash names, and we use those for comparison, right? So this default texture by name is literally just integer compares right here, right? Super fast stuff. So it literally just checks all these default texture names to see if it matches one of those, and if it does, it returns that. So that's that. And then if we actually found a default texture, we check to see if a callback was provided. Callback is optional, right? So this is a user callback that would be made when the texture is actually loaded, right? And then we can pass a listener along as well. So that listener can be a pointer to anything. It could be a pointer to a system or a pointer that's waiting on whatever this resource is to be loaded, right? So whenever the resource is finished loading, this callback is made. Since here we're getting a default texture, it's already loaded, so we can immediately issue the callback, right? And then we return T, which is a pointer to a texture, right? So that's that. If it is not a default texture, which is going to be the case most of the time, we go ahead and we build up a request, right? So in this case, we set the listener in the callback. Our request type is a texture resource. We have a single asset here because we'll have a separate function that handles layered textures and things like that. So in this case, it's a single asset, a single image asset that takes in, the package name and the asset name. And then goes ahead and sets the request array size, texture type, and flags, and then goes ahead and makes that request to the resource system. So it's basically saying, hey, resource system, load up a texture using this asset, and return to me a pointer to that texture, and let me know when it's done loading if the user requested that. So that's more or less what happens here. And then here we just check to say, hey, did the request itself at least succeed, right? We don't know about the end result of that request, but did the request get received? Was it configured correctly? Did it actually kick off the request, right? Did it kick off the request, which would kick off a multi-threaded job, etc., right? So if that did not do the thing correctly, then we will bleat about it, right? And we'll get the name of that texture that the request was for, right? So just kname string get reaches into that global lookup table where we keep a copy of the original string. So it'll bleat about that and then return the texture or a null pointer depending on what was found, right? And that is the way that the request works, right? So that way we always have an immediate pointer to a texture, whether or not the texture request succeeds, right? So we might we might fail down the road, but at least we'll be able to look at the resource and determine that. All right. I heard a couple dings, so I think we got some chats here. Let me just catch up real fast. Interesting stuff. Thanks. Yep, no problem. Cool to see a solid logging implementation and explanation. I'm glad it helped. Are you doing ZII? ZII. I can't say that I know what that stands for off the top of my head. Maybe I'm just drawing a blank, or maybe it's like streamer blindness or something, but can you expound on that a little bit? Matthias88, thank you so much for the tier 1 sub. I really appreciate that. That support means a lot. Thank you very much. I very much appreciate that. That helps me out a ton. First time chatter also, so welcome. I've been watching this stream for the last 15 minutes and I could say I finally found some quality programming content. Well, I'm glad you think so. I really appreciate that. And thank you for the kind words. And thank you very much for the support. I appreciate it. Tamandua, how's it going? Good to see you. I hope you're doing well. How are things? All right. So that was the request. I think we covered both the requests and let's see. I think the only other thing was release, maybe. Which here, yeah, this was the last thing that we changed, right? So texture system release resource, right? Or texture system release. That should probably be resource release, actually. That's kind of backwards, but all right. So what this does is basically it ensures that it's first off not a default texture, right? If it is a default texture, then it does nothing, right? Because we don't ever want to release a default texture this way. So this is like if we release a material or something and we release a handle to a texture, this is the way that we would do it. So if that material failed to load one of its textures, and we're for some reason using a default texture, for example, that's where this would kick in. And so we don't want to return, or we don't want to release those textures in that case. So we don't, right? We just boot out early. Otherwise, we call our resource system directly to release that resource, and we're done, right? The resource system handles all of the reference counting, auto release of its resources from the GPU, CPU, whatever, as needed, right? So we don't have to handle that anywhere else. And we're going to be removing a lot of logic out of the texture system that handled all that stuff for us because it's all handled in one place now. Thank you for the follow. Appreciate that. I am doing great. How about you? Tammin, I am doing great as well. Let's see. I think it's Jonathan Blow that did a video about memory management. From what I understand, it's basically zero initialization. Okay. And strive to always provide a default object no matter what happens. Okay, yes. Okay, now I know what you're talking about. It's been a while since I've seen that video, but I do know what you're talking about. There are things that aren't written that way in this engine, but I'm actually slowly converting things to work that way because it makes a lot of sense. It was Casey Muratori. Was it though? I could have swore it was Jonathan Blow because I vaguely even remember seeing it like written out in Emacs. Maybe I'm wrong. Or maybe Casey was the first one to say it and then Jonathan sort of repeated it. I don't know. I remember seeing it like on a Jonathan Blow clip, I think. Zoom Banka, good to see you. Thank you for the follow. Appreciate that. Maybe we're not talking about the same video, but I think we're talking about the same concept, right? So it's like you basically have your default state of 0 be valid for all the resources that you're working on, because that's the way that things are initialized in memory. Typically, is all zeros, right? So 0 is a default but valid state for things, I think is what you're talking about. Yeah, I could have swore that was Jonathan. Also, SDL3 is now integrated. Oh wait, I read that out of order. Started implementing your own renderer using OpenGL 4.5 with DSA. Also, SDL3 is now integrated. Nice. Awesome. That's good progress then. All right. Giannis over on the YouTube side says, do you recommend reading the Game Engine Architecture book by Jason Gregory? Yes, almost daily. Almost every stream it comes up, actually. In fact, I literally have it here on my desk. Highly recommend this book. I can't recommend it enough. I've read through it probably a dozen times. I'm working my way through it again, actually. Just because it's that dense with information. Yeah, it's a really good book. Vulkan is wild. So much boilerplate for Hello Triangle. Yes, but here's the beautiful thing about Vulkan is once you get the basics down, once you have like all your descriptor handling sorted and all that kind of stuff, there's not much that you have to do to change it. Like we don't have to touch the Vulkan layer very often, and when we do, it's usually not very widespread. OpenGL is not quite that way. OpenGL is very quick to get started, but to add features, you're like constantly touching it. All right. So I think that is where we left off for the most part. So where I was working is in the material system that makes use of the texture system. So I've been going through here just kind of resolving errors. And there's a lot in here. I've marked a lot of to-dos in here. There's a lot of things in here that I want to change, actually. There's some assumptions that are being made in here. There's some old hard-coded stuff from back in the tutorial days that I want to get out of here. I don't know that I'm going to get through a lot of that now, but I'm at least kind of going through and trying to mark it as we get there, right? So where most of the work dealing with textures deals with in here is this assign map function, which has now been rewritten. In fact, I'm going to close this other buffer over here. So this guy now takes in the material system state as its first argument, right? So we don't have to pass that around or get it. It uses the new k-resource texture map structure. We're still sticking with the old material map configuration for the particular material map that we're working with. I'm hoping we don't have to switch away from that. And then we also have the k-name material name and the k-resource texture default texture. So this is a pointer to a texture to use should the loading of the texture that is configured here fail, right? So if this doesn't load the thing correctly, then we use the default texture that's provided here. So basically what we do a quick check to say, hey, do we have a texture name and is the length greater than 0, right? Because if neither of those things, like if we pass an empty string or we don't pass a texture name at all, we obviously can't load a texture, right? So in that case, we go ahead and we just, in that case, we go ahead and just use the default texture, right? We just fall back to that. Otherwise, we go ahead and we use our new texture system request, right? So in this case, we have, we do a k-name creates for the texture name, right? So we do that. And then we pass invalid k-name for the package. And this is something I have a to-do on as well. So the way that this is supposed to work is when we load up a texture, we load up the k-name for the texture, right? The name of the texture we want to load. But also we specify the package we want to load it from. And currently, our material config does not have the concept of packages because packages are something new we've added. So what I got thinking a little bit about this offline. I think I know how I'm going to solve this problem. So when we, for example, if I go into our test bed, right, which has its own assets and it has its own materials, right? The testbed kapp is the name of that package, right? So that's our asset manifest there. And so since the material is loaded from this package, right? I'm thinking whenever we load up the material that we also save off the package name as part of the material's configuration, so to speak. And then we say, okay, well, let's search that package name first. And then if we don't find it there, we can search through other packages. That's the thing that makes the most sense to me. And so actually include materials package name here first, right? Just so we don't lose sight of that. And in this case, the material itself doesn't really care when this texture is loaded or unloaded or whatever, we've got ways to handle that. So we don't have a listener or a callback that are included in this request, right? And so since we return a direct pointer now, we can now say, well, the texture map's texture that's assigned to it is just a pointer to the texture that we request here, right? So it'll already either be loaded or it will kick off a load, and it'll return to us a sort of uninitialized, unloaded texture here, but can fall back to a default texture to use while that's loading. So if we issue this request and for some reason we get nothing back, then if we have a default texture provided up here, then we issue a warning saying, hey, we failed to make a request for this, but we're going to fall back on the default. And that's what we do, right? We just use that. If we don't provide a default texture for this, then that's an error, right? And this operation at that point fails, right? So we bleat about it and we return false. And then down here, let's see, we've already discussed this fall through. The next thing that we do is if we reach this point, we've successfully made a request for a texture. So we do have a resource one way or another that we can use with that. And so we acquire texture map resources, which as far as Vulkan is concerned, that's a sampler. So we go ahead and we acquire those internal resources from the renderer. If that fails, we return false after bleating about it. Otherwise, we return true and we're done, right? So assign map is called in, I think, 8 different places in code. And so now we just have to kind of work our way through those examples and fix them. And that's sort of the next step as we go. Let's see. Let me catch up here. OpenGL also implemented SpurV via extensions. Okay. But I need a bit to boil inside OpenGL than Vulkan. You use ECS. No, we don't really use ECS, no. We do have a concept that's, it's more like a decorator concept. So what we have is in our scene, we have a concept of nodes that can have attachments. And there's certain known types of attachments that can be attached to a node. And nodes can have, they can either have a transform or not have a transform, but they can always be parented and childed to one another. So there's always a hierarchy there, although that hierarchy is maintained in a separate tree. So we've actually separated concerns there as well. So we basically have, our scene provides us different views of the same sets of data, so that we can have our data locality within our different types of attachments, but we can also have a tree view if we need it, etc. So we don't have ECS. We do have a scene that kind of manages some stuff like that kind of for us. It provides similar functionality without all the indirection all over the place. We are going to implement a ECS as a plugin, but it's never going to be a core part of the code. And the way that this engine is designed, you don't even have to use the scene system if you don't want to. The scene system is there for your convenience, but if you want to write your application code to actually just render stuff manually, and you want to define that render loop manually, you can do that. If you want to use the render graph that we have, you can do that. If you don't want to use it, you can do that too. So we kept things very, very open in terms of the way the engine works to let the application drive how it actually wants to use the engine. Long-winded answer to that, but that's the reason I answered it that way. Is because, it kind of required all that explanation. Kason, is that your flavor of JSON? Yes, so to speak. Yeah, it's, let's see. So it looks similar to JSON, but it is not JSON, right? So one big difference is we don't require commas all over the place. But we do have all of the basic types that JSON has, right? So we have numbers which support either integers or floats. We have strings. We have the ability to set up objects, arrays, which can be mixed types, and booleans as well, right? So we have all of those different things. We actually wrote our own tokenizer and our own parser to handle this, complete with serializers and all that stuff too. So we don't have reflection yet. That's the piece we're missing. So you have to sort of manually write serializers, but we do have all that stuff. And we have ads. I actually wish you success. Making an engine is okay, but also using C with implementing kind of everything is wild and brave. Yeah, you aren't kidding. I've kicked myself a few times, but, you know, I get past that and I just move on. Part of the challenge, like using C was part of the challenge of this project, right? Because I've written tons of C++ game engines before, but I'd never actually, like my C++ always looked a lot like C. So I'm like, why don't I just write a game engine in C? So that's what I'm doing. Wondering how you handle loading of mixed type arrays. We do handle that. Yeah, so you can have an array of you can have an array where the first element is a number, the second element is an object, the third element is another array. Like we can have all that. Let's see. Casing is so cool. It looks like my syntax I use. Curly braces for list, square braces for object creation equals to set a property, but I use comma to separate them and semicolon to end the property list. Yeah, so we don't require any of that stuff, right? So in this case, everything between these guys is just a set of properties, right? With a property name and then a value of a certain type, right? In an array, and actually the internals of this. So an array here is actually built exactly the same way as an object. The only difference is the elements are not named. So they're treated exactly the same way in code. It's just the properties, quote unquote, of an array are just unnamed, but they're still properties, and that's the only difference. C enforces strong types. So do you have to split them, or how do you access this stuff in C code? So that's where our serializers come in, right? So typically we access things by property name, right? So I'll just say give me the thing out of the root element called a package config, right? And then that'll give me an object, and then I can say, okay, within the object, give me a property called packages, which will give me an array. And then I'll say, okay, well, how many entries does this array have? Okay, well, give me the thing that is the first element of that. Give me the thing that's the second element of that. And within that, it'll tell me what the type of that thing is. And then it's the same way for, objects, right? So I have this array of objects here. So it says, give me the first, I'll say, give me the first element of that array. Okay, it's an object. Within that object, give me the thing that's called name, right? And it'll give me this value, et cetera, et cetera, et cetera. So void pointers everywhere. I don't think we use void pointers at all in our parser. I don't think. I could be wrong about that, but what about multi-line string literals? I don't handle it. Yeah, there's some things I just don't handle. That's one of them. I could, I suppose. Or actually, maybe I do. I don't remember. That's escaping the backslash character. Oh, wait a minute. No, this is escaping quotes. So that's handling quotes within a string. Um, yeah, that's the only place. Yeah, we don't do it. I thought so, but I wasn't sure. Anyway, we have tokenizers, we have serializers, and we also have ads. It's true. That would have been a better segue for ads, actually. All right. So assign map is rewritten. Let's go to the next error in the file. So this one is in load material. So we are loading, this is specifically for a PBR material, right, where we pick out the maps. So here's the configuration map counts. I think there was some stuff we actually had to rework in here too. Because I know we ran into an issue where the order of the maps mattered. And I don't remember if we actually fixed that or not, but I'm not going to worry about it right now. We'll worry about that as a secondary issue. Okay, so assign map, too few arguments. I think this is missing the... No, we do have default texture. What is this missing? Oh, it needs the material system state. So, do we actually have... I'm assuming we have that. Or not. We do not have it. Okay. Well, that's kind of lame. I think, is this one of the things where we actually had a static? We do. Okay. So this is another thing I'm working on getting rid of. We have a lot of these. This was sort of an old way that we did it that really didn't work out too well for like hot reloading. We have these static pointers to state, right? And the real memory is owned elsewhere, but we kept kind of a convenience pointer that was stored statically here. Remove this and references to it, right? So we need to do that at some point because we actually have a global way from the engine now to actually retrieve that properly. I think what we should probably do, let's see, load material. How many? We only have 3 calls to this. Well, actually, no, we have 1 call to it. Really? Okay, so I'm just going to change this function to take in state instead of doing it inside of here, right? So we're going to do material system state, and then I'll do the same thing here. Material system state, and this is actually an externally facing function. So I guess what I'll do is, for now, I'll plug this in here. We're probably going to wind up getting rid of this too, but we'll do material system state equals engine systems get material system, right? And then we can just do state, right? So we have that sort of, that global way of handling that. So now in our load material, we have state available wherever we need it, which happens to be right here. Okay, so the next bit of this is not going to be quite so easy. So the differences here is our function assign map now requires a bunch of different types that we don't have. Let's see. So our config map is the same, but our material maps have actually changed. So we're going to actually have to update that to use the k-resource texture map type, because right now it is using the old texture map type, which we're eventually going to remove. And they're remarkably similar, but the reason we changed them is so that we can keep track of everywhere that we are having to change them, right? So we'll change that to use the new type, and then let's see. What wants the material name, which I think is going to want a K name, I'm guessing. Yeah. So the material name in here is actually just a character array. It's not even like a dynamic string, which is kind of terrible. I think I'm actually going to get rid of that and replace it with a K name instead. Just outright. K name, right? Do we not have strings K name? There we go. All right. So that's going to use that hashed version of the name, right? So we'll have places, we'll have Fallout, we'll have to fix that as well. And then default textures is actually going to be also, it's using texture pointers, which is not correct either. That's going to be K-resource texture, which means that these also need to use the K-resource versions of those, which is also going to require, that requires a pointer to the texture systems state. So my question is, do we have in our state? We do not. All right, so let me go ahead and get that sorted out. Let's go to initialize. So we know for a fact that our material system is always stood up after our texture system. So it's perfectly reasonable for us to go ahead and store off a pointer to that. So in here, we're also going to keep a pointer to, if I can spell struct right. Thank you for the follow. The texture system state. Texture system. All right. Then we'll do state pointer, which is actually, I need to fix that too and get away from that. Texture system equals engine systems get texture system. We're doing all kinds of state pointer stuff in here, and that's rubbish. We don't want to really be doing that. We really should be using, first of all, this shouldn't be a void pointer. We need to get away from that too. We've done this in a lot of other systems. We haven't done it in this one apparently. So we just need to use the sort of forward declared version of this structure, right? All right, so let's go to the header file. And here's the material system config, which we should also swap out for this, right? So let's do, oops. This should be material system config, right? Which we do have right here. But we're also going to forward declare struct material system state. Whoops, I don't want to do that. All right. And we're going to do struct material system state. Right, and then here we're going to do material system config. Oh, and you know what? There's actually one more change I want to make to that. Material system state. Let me go back to the header file for a second. This should be a constant pointer. All right, we shouldn't be modifying the config within here. All right. So we get this when we create that. Now that's typed, so we don't have to do all of this poop in here. I'm still going to leave this for now, but we are going to remove that. Okay, so now I can just do state, right, and set these things directly. Okay. This one, here's another one. Might as well get rid of a lot of these now. All right, this is just all of our initialization code for the system. Not a huge deal. We're just kind of using that static variable that I want to get away from. So since we're in here, we might as well do a little cleanup. All right, we got that one and that one. All right. And then this one actually is another one that we need to do struct material system states and struct material system states. Now we don't need that S, right? We can just say state. And we can do the same thing here. Right? Get rid of all that cold casting that was happening and just use the actual type. All right, and I guess this will come out when we remove that thing. Let's see. Does kname have SSO? SSO. What do you mean by SSO? Small string optimization. Oh, you're thinking of k-strings, which actually is not fully vetted out yet. But yeah, a kname is just a integer, is all it is. So yeah, no, it doesn't have that. Do you use pound embed? Seems Clang and GCC support it, but MSVC not so much. They slowed development of MSVC. Yeah, so I try not to use extensions of any kind too much. And that's something that, like, embed, I think, is just like an extension that I think Clang and GCC they enable by default, but yeah. All right. All right, back from that slight detour. So yeah, we are going to have some more errors in here. Looks like we have 16 actually, and that's probably from the name, right? So let's see, what are we doing here? Acquire terrain material. Okay, so this is doing a string end copy of material name to the material's name, which is now a kname. So this eventually is going to wind up changing to a kname, but for now, what we're going to do is we're going to say material name equals kname create, and that's going to be past material name. And that'll give us what we need there. So that'll solve that one. Probably going to have to solve that in a few other places as well. All right, so incompatible pointer types, not surprised. So that is because our material maps now use the k-resource texture map instead of just texture map. So that's just k-resource. So that should fix that one. Let's see. Texture system acquire textures as arrayed. And that is taking a string, which material name is no longer. Let's see, what was this one doing? Was this... I think this is the one... Material name... I don't remember exactly what this one... I think this is for our like cube maps and the like. Which hasn't been converted over yet. I feel like I should convert this now before we actually, instead of changing the code on this side. Because that's also going to return the wrong pointer type too. Because it returns a texture pointer instead of a k-resource texture. Which is, texture pointer is the old type, k-resource texture is the new one. So yeah, I guess let's refactor this one. So this is going to be kname, kname, name, layer count, layer texture names. So this is where we load a layered texture, or we basically take a bunch of texture files, right? You can think of it that way, or a bunch of texture assets, and we load them into a single texture, a single layered texture, where each one of those layers is that file name, right? So we use this actually for terrains and potentially cube maps, right? So this layer texture names probably should also not be a string. It should probably also be k-names, which is just going to be that, right? Not tied to a file name, only used for lookups. Okay, that's fine. And then layer texture names. Names of textures to load, one per layer. Textures must be the same. Okay, so this is actually... We shouldn't call this texture names, right? Because we need to make a separation here. Technically what we're loading here is assets, right? So we're loading a texture using the names of assets. So we should probably... That's one of the reasons this is kind of confusing. So this should actually be layer asset names, right? And it didn't used to be separate before, but now it is. Right, so the name of the image assets to load, one per layer. All image assets must be the same dimension. Size of array must match layer count. And then we choose whether or not we want auto release, which I think is fine to leave that there. So the only other change we need to make is k-resource texture, right? And then we can go to definition here. K-resource texture. This now becomes a, whoops, k-name. And then we have here k-name, k-name. And this is going to be layer asset names, right? Okay, so we must always have at least one layer. That makes sense. Now, this is doing stuff a little bit different. So we have this process texture reference, which is our old texture system reference counting. We no longer need that at all, I don't think. I'm going to comment it for now. And we also have this registered textures, which we're not going to use anymore either. That's part of that sort of caching system that we had. That's now handled for us by the resource system. So we're getting rid of a lot of this sort of duplicated name lookup stuff all over the place. K-name came confirmed, yeah. Code Void, how's it going? Good to see you. Why so many comments? So what I'm trying to do is this is all used to generate our code documentation. So if we take a look at KohiEngine.com. We have API documentation. And somebody called it in the chat. It's Doxygen. Yeah, so we can actually come in here and check out. This is a little bit out of date, actually. I think my build process for this is broken, just because I've done a lot of refactoring. But like if I do, I don't know, containers, I think darray is a decent example. It generates all this stuff with explanations, right? So we have all of this, if folks want it, right? So that's the reason. We don't have it throughout the whole code base yet. I've done it on a lot of the older types and a lot of the stuff that doesn't change too much. And I try to keep it up to date as I go. A lot of the sort of public facing code I will do this with. Anything that I don't export, I don't necessarily do this with. This should also be exported, actually, and it's not. Okay. So okay, that makes sense. All right. Editors can also hook into it for code hints, completion, etc. Yeah, which ours actually does right there. Right, so if I get information on it, it actually pulls that all up. Yeah, so there's multiple reasons behind it for sure. It's pretty nice to have that, especially when I write something and then don't touch it for 2 years and then come back to it. Is KAPI DL export a thing in Windows? That is what it's for, yeah. It's also, there's a version of it for GCC/Clang as well. So, yep. Because by default, I actually set up GCC and Clang to not export symbols by default, which it does by default. So, the reason that I have that is so we can be explicit about what gets exported and what doesn't. Okay, so needs creation. Okay, so actually a lot of this stuff is going to, let's see, create texture. I think we can actually use this. So I'm just going to copy pasta this. You know what? I actually need the state too. So let me get that. We are going to have to change some of the parameters, but that's fine. All right. So the main difference here is this is a texture type 2D array, right? So what we're going to be doing is, you know what? I'm just going to actually, I'm going to do this. Let's clobber this whole thing at once. All right. So let's see, callback. Do we want to allow a callback here? Because again, this is sort of our old acquire pattern. I think we probably should allow for that. Let's go back to the header. We're gonna change the way this works. There's not too many things that call this, so it's not a huge issue. So we should include. Oh, wait a minute. We didn't do that for request writable. No, because that's immediate. So that doesn't need a callback. But anything that loads a texture, right, has a callback. So we should probably do this and change it to be called request, right? Yeah, I think that's going to be, let's put it there. So we can optionally pass a listener and a callback, right? And so basically it'll issue the callback once once the textures are all loaded, once all the assets are loaded. And it'll pass along this listener as part of the context of that callback. So, you know what? Don't I have... I think I have... oh, I didn't write a comment for this one. What a dingus. All right. I'll write this one, I guess, then, and I'll copy the comment later. So let's just update this one. At param. Oh, we have ads. Thank you for the follow. Thank you for the icon there, Ruche. Appreciate that. What the heck does texture system reticulate splines do? Me after 2 years? Yeah, you're not kidding. After 40 years in development, STD print is worth the wait. Maybe. I don't know. I probably won't wind up using it. Actually, what C++23 achieves with STD print practically has been implemented in C as printf, but without the derived custom types. C++, what a modern language. Sarcasm. Yeah, I agree. I agree. They just keep adding more ways to do the same thing, which is not particularly helpful. Sometimes they'll add a useful feature like C23 is going to have a limited version of const expression, but I don't want to use C23 because not a lot of platforms support it. So, especially if you go to port to console or something, which I do want to do, we're going to back ourselves into a corner if we do that. Ads are almost done. Lol, printf. Yeah, I mean, eventually we're actually going to write our own sort of printf and get away from using actual printf. But for now, we still rely on it, kind of, for some things. Okay, so in this case, listener, a pointer to, I guess, let's just say, yeah, a pointer to something listening, or I guess something that requires the callback to be made once the resource is loaded. I hate the way that's worded. I'll probably change it later, but and then we have callback, which is a callback to be made once the resource is loaded. Okay. Let's grab these because I'm going to need those in the Thank you for the follow. Appreciate that. Welcome. Oops. Paste. Okay. So that's that. Did I note that those were optional? I don't think I did. Right, those are definitely not required, but I want them to be there in case whatever is calling this needs it. All right, so we create a request. Here's the base request for that. Now, we have an assets array that we create, which before we were just sort of hard coding to 1 for a texture 2D. But in this case, and while I'm thinking about it, this needs to be texture 2D array, right? Because this is an array texture. So we're going to be creating a list of assets, right? So what did I say that was? It was layer count, I think. Yeah. So we're going to do layer count here for that. And then we're actually just going to u32i equals 0, I is less than layer count plus plus I. Right? And what we'll do is instead of repeating all this crap below here, we're going to say, let's see. That's the asset info. K-resource asset info. Okay, so let's just do info pointer, and we're going to call this asset, and that's going to be the address of request base assets data sub I. Right? And now what we can do is this. Oops, I want that. And then we're going to say, what did I do? I hit the wrong button. I want this. There. All right. And package name. We meet again. We don't have that here. So we need to add that too. And I'm pretty sure, let's just do this. The name of the package from which to acquire the textures. All right. Ideally, all those should be in the same package. They don't necessarily have to be. The resource system will take care of looking that up. This is basically just an optimization to say if we know what the package name that they're in, we can provide it. But if not, it'll basically just go through all the packages and look for it. So either way, we'll find it. It's just a little bit of a optimization if we can provide it. So here, kname, package name. All right, so that's provided there. And then the asset name is going to actually be, what did we say? Layer asset names, right? So that's going to be layer asset names sub I. All right, so each of these assets is going to be an image from the following package, and here's the asset name. All right, so those all get rolled up into that array. The request array size, this is the texture array size, is also going to be layer count, right? So array size here is the texture array size, not the number of assets, right? We've already set the texture type. Flags, I don't think there's anything on that we need to set. Then we go ahead and we request the resource. Let's go ahead and say arrayed texture just to make it a little bit more explicit. And that's it. We're done. All right. Let's see. I was trying to ask, do you know of good resources on how game engines handle audio? It's pretty easy stuff to find stuff about rendering, ECS and the likes, but I've not been able to find stuff for audio. So audio is a pretty in-depth topic, right? So the thing about audio is, for every platform that you intend to support, there's at least one way to go through it, way to go about it, like API, right? So Windows has, what do they call it? I want to say it's direct sound, or is it direct audio? I forget. I think it's direct sound. And then you also have like the Windows multimedia stuff, and you have a few different ways to do it on there. Mac OS has 2. Linux has like 6, right? And so audio is kind of a little bit like it's kind of a little bit like GPUs used to be when they were brand new back in the day, like back in the 90s, where you had separate APIs per GPU manufacturer even. You didn't, like, this was before OpenGL, right? And then you had OpenGL that came along where all that stuff was sort of embedded in the actual driver itself, which is kind of the way it went going forward. But audio kind of never really got something quite like that outside of OpenAL, which is what we're actually using for our sound system here. So we did actually go through an entire implementation on that in this series. There is, if you search in there, there's a couple of videos about it where we actually step through it. Resources on how to do it, I basically just looked up how to use OpenAL, read the documentation, and had to figure it out the hard way. Unfortunately, I don't know of any really good, solid tutorials on how to do it. OpenAL it kind of looks a lot like OpenGL, but for audio. And the nice thing is that it abstracts all of those audio APIs for all the different platforms for you. And OpenAL is, there's only version 1.1. It's been around for ages and it's never been updated. It's kind of a solved problem, right? So you have OpenAL is one option. There's other ones out there, like Fmod is another one. So it really depends on what audio package you want to use. They all have different licensing, right? The reason I chose OpenAL is because I can open source what I write with it. Fmod, I don't know about that. I think there's some pretty strict licensing and fees and stuff associated with Fmod, right? It's not, you can't just take it and use it, especially if it's like commercial, right? So there's things to consider there. Let's see. Was KAPI there a part of a return type or some kind of macro magic? It's a symbol export, right, is basically what it comes out to be. So if we take a look at this. I'm on Linux right now, which basically says set the visibility of whatever comes after it to default, which we actually set that to hidden by default. We overrode that. If we're on Windows, it uses, it's basically decal spec DLL export, right? So it depends on what platform we're on. It does a little bit different things, right? And then it depends on whether we're exporting or importing that, and that is defined by our build process in terms of whether we're actually building a library or building an executable. Pipewire, go wild. Yeah, exactly. Yeah, there's Pipewire, I don't remember all of them for Linux, but I started looking into it and I'm like, I am not implementing all that stuff and then supporting it. No, thank you. So yeah, OpenAL is kind of a solved problem, thankfully. And it's worked out pretty well for me. It gives me spatial audio and everything, but you have to manage all of the buffers and stuff yourself, right? So it's a bit lower level than just saying play this audio file. You actually have to load up the audio file, decode it, and then feed OpenAL, the raw data that it needs. So yeah. Okay. So that, I think, is good to go. So let's get rid of this. I don't think we need that anymore. And go back to our material system, which is what kind of kicked that off. So in this case, we acquire textures as arrayed. And we're doing, obviously we have now too few arguments, right? So we need to add some stuff. But also I know that these texture names are not what we need either. So our texture names, where is that defined? I think it's up here somewhere. Right there. So this needs to be kname array. This needs to be size of kname. This crap I don't like either, but we'll fix that in another pass. So for our texture names now, instead of string duplicating this, which is because we were keeping it in string format before, we're going to take this and say kname create, and now we have a kname, right? So that's done. Let's see, what else? What are we missing here? I think it's just, oh, so we need package name, right? Let's see, do I want to add, I'm going to add package name here, right? And the name of the package containing this material. That way I can do m package name. And then I think the last two are just listener and callback. Yeah. So in this case, we don't actually care when they load up. We'll just try and use it anyways. And then if we have like a some sort of default that we need to use, we'll do that instead. So we're going to pass 0 for both of those. We don't care about that, right? So that fixes that issue. And now we have, if we don't have that, we get the default terrain texture. Now this is something, again, that needs to be fixed, right? We need like default layered textures, but we need them with like different layer counts, right? So I think we're gonna have to like adjust our approach there. But I'm not gonna worry about it for right now. We're just gonna convert that to use the K-resource version. And this also requires the states. Do we not have the state? We do not. Okay, I guess in this case, we'll just acquire it here. We'll just grab it. Default terrain material. Yeah, I guess that's fine. Okay, so let's do material system state. State equals engine systems get material system. And then here, this just requires state. Oh, and we also require, let's see, get default wait, what is this complaining about? Incompatible point, wait. Oh, what a dingus. I need state texture system. And then this is returning a K-resource texture. Oh, it's returning a const. Actually, though, now I'm thinking about this, a texture map should have a constant pointer to a texture. It shouldn't be mutable, right? So let's actually change that. This should be constant. And let's say a constant pointer to a texture resource. All right, because we should never be like modifying. We shouldn't say map.texture or map arrow texture set a property. We shouldn't ever be doing that. Okay, so render texture map resources acquire. This needs to be resources. I think we have K-resource texture map is what it was. Okay, so And then I believe this also requires the renderer state. So state renderer. All right. We have read this from config. Yeah, that's a good point. Why are we not reading that from config, actually? Do we not have... Do we not have that? I thought we did. Material config. Maps sub I. One map is needed for the entire material array. Oh. Right. Okay, so typically we would get that from config, but in this case we have, wait a minute. This works a little bit differently. That's right. So terrain materials are a little bit different. So I'm going to leave that to do for now, because we're going to change the way that these are read in from configuration anyway. So I'm not going to deal with that right now. I'll come back. Els Dragoon with a raid of 30 viewers. Welcome. Thank you so much for the raid. Raw roll sub, dude. If you guys are not following Els Dragoon, they are a duo who are creating an NES game in assembly. And it's a super cool project. If you guys are not following Els Dragoon, there's a shout out. Definitely do that. You got a big boost from Practical NPC right at the end. Nice. Well, welcome, readers. We are in the process of actually redoing a lot of our resource handling within our engine. So actually it occurs to me that you guys probably don't even know what engine I'm talking about. So let's actually back up for a second. So what we are working on here is something called the Kohi game engine. I'll drop a link to this website in chat. And basically what this is it's a game engine that we're developing from scratch in C. With a Vulkan backend, at least initially. I say initially because we are going to support Direct 3D as well as Metal natively in the future. But for right now, it's Vulkan, and it started off as a tutorial series on YouTube, and we changed formats a few times, and eventually landed on this sort of live stream format. So the idea is it's a way to build a game engine. It's designed to be a educational series, right? So it's a way to build a game engine, not necessarily the only way to build a game engine, not necessarily always the right way to build one. Sometimes we do a little bit of exploration and trial and error just to try stuff out, see what works, see what doesn't work. And so this includes everything from design discussions to trying to implement features, refactoring sometimes when something doesn't work out, debugging, all that stuff's included here. And the idea is that you get to see everything that goes into building a game engine completely from scratch. So we have as few dependencies as possible, and we're basically building the whole thing in C. The engine itself is available on GitHub. It is free and open source. It is right here. It is Apache 2.0 licensed, which basically means if you want to use it personally or commercially, that is totally fine. All that I ask is that you say that you've used the engine, right? And so there will never be any sort of licensing fees or royalties of any kind. It's always going to be open source and free. It's designed to be educational, and I believe that this kind of thing should be freely available to inspire more people to want to write game engine technology, right? Competition is always a good thing, and we need more of it. So That being said, we have lots of links here on the website, obviously to the GitHub, our Discord, which is approaching like 1,000 people, I think, our YouTube and Twitch channels. We do simulcast to both, by the way. And then a Patreon link if you like what I'm doing. You can support it. If not, that's totally okay. I appreciate you guys either way. And then the live stream down here at the bottom. We also do have API auto-generated documentation here available as well. I was showing that off a little bit earlier. So that's available from this API documentation link up here, right? And yeah, so that is basically the project as a whole. I've got a couple screenshots on here. I can't really show it running at the moment because we are doing some refactoring, so it doesn't actually build at the moment. But we have a very basic PBR system in terms of lighting, cascading shadow maps, LOD terrain, basic skybox. We have a water plane that we recently just put in with refraction and refraction, all that stuff. And we have some editor tools built into it, like to be able to move and manipulate objects around the scene, raycast picking, all that kind of stuff. We do have full UTF-8 support for fonts. The only thing that we don't support currently is right to left fonts and fonts with like connecting like little ligatures and stuff like that. We don't support that yet, but eventually. But yeah, all the information about that is here on the GitHub in terms of like how to get it, how to build it, all that stuff. So I hope that all makes sense. And what we are doing is we are reworking our resource system and our asset system. We recently completely basically rewrote those things from scratch. So our resource system is designed to be asynchronous so that we can make resource requests on multiple threads. We can jobify that. And then our asset system is designed to be asynchronous as well. So the difference between an asset and a resource is the asset is a representation of the file off of disk, right? So you have the example I always use is you have an image asset, right? Which is like a JPEG, a PNG, a bitmap, something like that. That's loaded off disk. We get the pixel array data out of that, after decoding the image and so on and so forth. And that image asset could be used for a few different things. It could be loaded in and used as a texture in the GPU. It could be used for a height map for a terrain, for example, right? So it has, it's not necessarily a one-to-one relationship, right? So that's why we kind of split those two out. So the resource is the texture, right? Whereas the asset is the image, right? So that's the difference there. So those systems have been rewritten and separated out. The other thing is our asset system sits on top of a virtual file system that sits, that's also brand new. And then that sits on a packaging system, which allows us to split up assets into packages based on what they're actually included with. So our engine's very modular. It has plugins, for example. And so some of these plugins may actually include assets. Like our standard UI system is a plugin. You don't have to use it. The application can choose to use it or not, right? And so if we use that, it's got certain assets like some fonts, some shaders, some textures that come with that that wouldn't necessarily be included otherwise, right? So it's got an asset package of its own. Let's see. The other example is the test bed, which is sort of our test driving application. It has its own asset package as well that includes things like materials, models, sounds, music, etc., right? Textures. And so the packaging system allows us to package up assets and release them individually as like part of a game or part of a plugin. And then when we go to build the actual runtime or release version of the game, the idea is that those things would be packaged into large binary blobs that then ship with the game instead of having a bunch of loose assets on disk, right? So all of that was built, and now we are transitioning our engine to use those new things because it's far more flexible. And the other thing is our resource system is responsibility. Its responsibility is to own all the resources that it loads. So all of our textures, our sound files, any kind of resource is owned by the resource system. So we don't have to worry about ownership or life cycle of those things. We simply obtain references to those And the resource system has an internal reference count system that it uses to determine, hey, if we load a resource and we use a resource and we have like 3 uses of that resource, and then all 3 of those references are released. If it's configured to do so, it will also then automatically release that resource from the GPU or whatever, right? And so the idea is that the application shouldn't have to worry about that stuff. It can simply just say, hey, give me a texture, and it'll return a pointer to a texture, and at some point that will be loaded, right? And you don't have to worry about any of that stuff from the perspective of the user code. So that's basically what we're putting in place now. I hope all that makes sense. I know that's a lot. Also, we're going to have ads starting soon, and I always like to pause the stream when ads come up so that nobody misses any content. So yeah, Els Dragoon, thank you for the raid. I appreciate the raid and run. I totally get that. But yes, I'm glad I was able to tune into your stream earlier. Awesome, and thank you for the lurk. All right, you're already following them. Awesome. Yeah, their channel is awesome. Totally awesome. All right. So where we were was we were basically kind of just converting this to use all of those new types, right? So we have these new K-resource types, like a K-resource texture, for example. And so we're converting from the old sort of just texture struct to a K-resource texture struct. And then we're going to remove all that old stuff out of here. And it's going to simplify things. Our texture system and our material system, for example, also maintained ownership of those things previously, and had their own each had their own like implementation of reference counting and all that stuff. Now it's going to be all referenced to one place, and we don't have repeated code all over the place. So multiple reasons for doing that, for sure. All right. So I'm just kind of going through and resolving the errors in this as we go. Ivo, how's it going over there on YouTube? Finally catching a stream again. Nice. Welcome. All right. It said ad coming soon, and then I don't think it ever actually did the ad. And now I see the ad's like 30 minutes out, so it must have run it and just not told me it was running it. So I guess we're not pausing for ads, because Twitch's dashboard is just wrong. Cool. All right, well, that seems fine. All right, so we basically just have to convert. So we've rewritten this as a assign map, and we basically just have to convert this to use all the new functions that we put in place. So texture system, we need that, and then material maps. I think this has already been converted. Assign map. I think this wants texture map, and then the config. Wait. Oh, it needs the material system state first, and then it needs. What's the last parameter? Should be a texture. The default texture. So why is it bleating about that? Oh, it's passing const. Oh, right, because we changed, because these default textures return a constant pointer. So we're actually going to have to change assign map, because actually the texture map itself also keeps a constant pointer to that texture. So we actually need to say this is const. And put const here as well. Oh, now the ads come up. I guess the timer was just way off or something. Don't know how it's going on yet. Just woke up. It's 5 a.m. Think all is fine so far. You're in Germany, if I remember correctly? I think. So yeah, I guess that sounds about right. Germany. Yeah, I thought so. Okay. I do my best to try and remember where you guys are. I don't always succeed at that, but... All right. I think we should be good on that. And I'm not coding anything. I'm just navigating the file as we wait for ads to conclude. We're almost done with ads, actually. And I see there's some comments on Twitch. I'll answer those in just a second. You want to create a simple game engine, but you only know C and not C++. Well, you're in luck because we're using C here. Although I wouldn't call this a simple game engine. Let's see. Bytemap, welcome. First time chatter, so welcome. I want to make a demo program to debug perspective projection. The goal is to debug perspective projection and see the transformation of objects from having a full depth being projected onto a 2D plane in front of a virtual camera. One camera applies projection and the second camera can see objects squished to 2D following a projection slider. That sounds more like matrix interpolation than anything else, actually. You're currently multiplying the projection and view matrices of the virtual camera to the model matrices for each object. The final debug camera then multiplies its own projection and view matrices to those transformed coordinates. I think I'm doing something wrong. Could you please guide me? It'd be hard for me to say without code. I couldn't debug that live, I don't think. But it sounds like you need to interpolate between different projection matrices, if I had to guess. That's what I'm guessing. But again, yeah, that's not really something I could debug here. All right. So I know a lot of you raiders just came in, but I do actually have to get up and work in the morning. And unfortunately, this is the time I normally end. So I would say if this is a project that interests you, I would say go ahead and toss me a follow. I greatly would appreciate that. I am trying to grow the channel. But we are going to pick up with this on the next stream. And if you check out the YouTube channel that I have, I've got all this stuff. All the VODs are available there as well if you're wanting to check out, you know, how the project began, right? We literally started from nothing, ground zero. So I'm going to pick somebody to raid. I was hoping to actually raid Els Dragoon, and then he got in here just right before I was ending. So I really do appreciate that. But you know, I do have to end, unfortunately, tonight. Let's see. Let me see if I can find something that's loosely related to what we're doing. I might like to find something new if I can, but I might actually wind up doing let's see. You know what? Let's go ahead and raid. Let's raid Hypnotic Games. See what he's up to. He's making a game called Corrupted Goblins. So we'll have to ask him about that. Definitely ask him about his game once we get in there. But yeah, I appreciate you guys being here. Thank you so much for joining me. And I look forward to seeing you guys on the next stream, where we'll continue this and hopefully, finalize this soon so that we can get on with our feature list that we need to make the game and actually start making the game. We're getting pretty close to that, but we're not quite there yet. So, all right. So yeah, with that, I'm going to bid you guys farewell, and I'll see you guys later. Thanks so much. All right. See ya.